Hey everyone, welcome back to the channel where we explore the latest in technology and innovation. Today, we're diving deep into one of the most exciting areas of artificial intelligence, deep learning. Whether you're a tech enthusiast, a student, or just curious about how AI is transforming the world, this video is for you. So, let's get started. First off, what exactly is deep learning? At its core, deep learning is a subset of machine learning, which is itself a part of artificial intelligence. What makes deep learning unique is its ability to learn from large amounts of data using neural networks with many layers, hence the term deep. These layers help the model understand complex patterns in data, making deep learning incredibly powerful for tasks like image recognition, natural language processing, and more. Imagine a neural network as a series of layers, each one processing data and passing it to the next. The input layer receives raw data, like an image or a sound clip. The hidden layers, these are the deep part, extract features from the data, like edges in an image or phonemes in speech. Finally, the output layer gives us the result, like identifying a cat in a picture. A neural network starts with the input layer, where data enters the network. Each neuron in this layer corresponds to a feature of the input data, like pixels in an image or words in text. Next, the data moves through the hidden layers. These layers process the input by extracting patterns and features, transforming raw data into something meaningful. This is where the network learns through weighted connections and activation functions. In the forward pass, the input data flows through the network, layer by layer, until it reaches the output layer. The output layer generates the final prediction, such as identifying an object or making a decision. After the output is generated, the network performs error calculation by comparing the prediction to the actual target, determining how far off it is. In the backward pass, also known as backpropagation, the network adjusts the weights of the connections to minimize this error. It calculates gradients and updates the weights in the opposite direction of the error gradient, improving accuracy over time. This cycle of forward pass, error calculation, and backward pass is how a neural network learns and improves. Each neuron in a layer is connected to neurons in the next layer, with each connection having a weight. These weights are adjusted during training through a process called backpropagation, which uses an optimization method like gradient descent to minimize the error in the network's predictions. But wait, there's more. Neurons also use something called an activation function to introduce nonlinearity into the model. This is crucial because it allows the network to learn and model complex data. Popular activation functions include ReLU, sigmoid, and tant. Now that we understand the basics, let's talk about the different types of deep learning models. Each type is designed for specific tasks. A CNN, or convolutional neural network, takes an image as input and processes it through several layers to identify patterns and features. Initially, the image is passed through convolutional layers, where small filters scan the image, looking for specific features such as edges, textures, and patterns. These filters produce activation maps that highlight the locations of these features within the image. Next, pooling layers are applied to reduce the size of these activation maps, which makes the network more efficient while retaining important information. After this, the network flattens these maps into a single vector. Finally, this vector is fed into fully connected layers that analyze the information and make predictions, like identifying objects in the image. All right, enough theory. Let's see how deep learning is used in the real world. The applications are endless, but here are a few highlights. In computer vision, deep learning powers everything from facial recognition to medical imaging. In natural language processing, or NLP, it's behind chatbots, translation services, and even sentiment analysis. In healthcare, deep learning is helping with early disease detection and personalized medicine. And let's not forget autonomous systems. Self-driving cars, drones, and robots all rely on deep learning to navigate the world around them.